So once we have our y versus t data, and this is not real good y versus t data, I just made these numbers up here. So that's probably not going to lead to a very good quadratic model. But once you've got the y versus t data, assuming the form y equals at squared plus bt plus c, because that's what physics predicts. Okay? We plug in our value of y and our value of t for each observation. So plugging in 138 for y, 8 for t, it's clear that we get this equation. 8 goes in where t is, and 138 goes in where the y is. Okay? And then we do the same thing for each line, and we get 5 equations. Okay, well, there's actually something we can do that takes account of all 5 equations, but we want to find the values of a, b, and c, because then we plug those in, and now we have our function. And we can use our depth function to predict what's going to happen in between the times that we measure, and to predict it with really pretty good accuracy if we've got really good data. Okay, so in order to do that, the first thing we're going to do is we're not going to use all 5 equations, we're just going to pick 3. So I'm going to pick, say, this one, and this one. Okay? Now, it should be clear that I could move the 20 over onto the right side, the 40 onto the right side, and the 138 onto the right side. And I would have then an equation of this form. Okay, now I'm going to have a matrix that can multiply A, B, and C to get 138, 40, and 20. Okay, the first row of the matrix will be h squared, 8, and c. So I have 8 squared times A plus 8 times B plus C equal to 138. The other rows will be 41 squared, 41, and 1, and 125 squared. 125, 1. Okay. Now I can expand the 8. Yeah, that's going to be 64. This is going to be, I think, 1761. And I should be able to do that, 25/16. That is going to be somewhere around 15,000. I should be able to do that in my head. 100 plus 25 squared, right? It'll be 10,000, and then 5,000, and then 25 squared. 1,565, I think. So this matrix could be that, so that let's pretend that I got the matrix right. That'd be 64, 8, 1, 17, 61, 41, 1, 15, 625, 125, 1. Inverse, that would have to do the inverse matrix times 138, 40, 20. I'd have to inverse this matrix, and you could do that. Okay? And the other thing is, we could also do this by reducing the augmented matrix. And we get our solution either way for A, B, and C. And we want to do this both ways. And that needs to be report results. Next class. In writing, well documented, and so forth, and I'll give you some words about that. Okay, so there's the first task. Now there are additional tasks. Once you have your model, you can see how well it fits the other two, well, not the other two equations, but the other two data points. You can plug 41 for t into your function, the function that you get when you plug in A, B, and C, and see if you get 83. You probably won't because there's some uncertainty in what we did. Plug 170 in for t, see if you get 0. Plug in 83 for y and solve the quadratic equation and see if 41 is one of your solutions. Plug in 0, solve that quadratic equation.